Hey there, Algebra 1. Mr. Catlin here with your Lesson 7 help for your cool down, and we're using graphs to find the average rate of change. So, real quick, just a reminder what average rate of change is. It is the difference, as I write with the line drawing tool, one of my favorite things to do. It is the difference of your outputs, okay, which are always on your y-axis, over the difference, and this little triangle just means the change or the difference in your inputs. So this is how we find average rate of change. It's very similar to your slope formula, y2 minus y1 over x2 minus x1. It's essentially the same thing. All right, it is the same thing. All right, so we're finding the slope, but we're doing it on function graphs. And so function graphs a lot of times can come in curves or weird shapes. And so we're finding the slope between intervals that they ask about. Okay, so this graph shows the interval of 1900 to 2000, so that entire century. But the first question asks what's the average rate of change between the years of 1930 and 1950. So for us on this particular problem, we're finding the graph at 1930, and then we're finding the graph at 1950, and we're finding essentially the rate of change between those. Okay. And so what we're doing is we're finding the slope, and you can draw it with a slope triangle between those 2 points, which would represent the average rate of change. Now, it's not going to be exact rate of change because that blue line doesn't match the red line that I drew. But on average, it should represent what's happening here. Now, we know that it runs a course from 1930 to 1950. It runs a course of 20 years. And over that 20 years, it looks like it goes from 40,000 in population up to 45,000. So our change in output, which is our vertical change, y2 minus y1, it goes from 40 to 45. So that would be a change in 5 over a change in 20. Okay, so this is technically 5,000 per 20, if you want to think of it that way, because we're going up 5,000. These are in thousands, so you can think of it more like this: 5,000 over 20, which reduces to 500 cut in half, which is 250 people per, or 250 people a year, which would, let's see, we would write like this: people, sorry, per year. So the population in this city is growing about 250 people a year. So my reasoning is over here, but we're going to write our answer of 250 people per year. That is the average rate of change between those 20 years. All right, so let's do these other intervals. What about, it just says, okay, so we don't have to actually do as much math on this one. It just says decides if it's positive or negative. So we just got to say, is it increasing or decreasing? So that's pretty simple. Let's just draw what the slope line would look like for these particular years. So 1930 to 1940, that would be from here to here, would be my gold line. Okay, and that was positive, right? And then from 1950 to 70, 50 to 70 would be on this blue line. So that blue line, that one's definitely going downhill, right? And then from 1930 to 1970. Okay, so 1930 again to 1970 would be here. Not as steep as that one, but definitely declining. So my answers for this would be positive, and then the last two would be negative. So we don't have to actually do any finding of the rate of change. We just have to be able to recognize whether it's positive or it's negative, upward slope or downward slope on the graph. All right, last one. In which decade, 10-year intervals, okay, 1910, 20, 20 to 30, 40, so on and so forth, which one of those did it grow the fastest? Okay, so we want to know the quickest growth. And a good way to narrow that down pretty quick is to draw lines of each interval. So let's do it with our line drawing tool so it'll actually show up a little bit straighter. All right, so we got our green line there, green line there. And I think they actually did this for you. So all of these lines have already been drawn. You're looking for grow the fastest. So everything on the right of 1950 is out of question. right? So we just ignore those completely. So we're looking at the slopes of these 1, 2, 3, 4, 5 decades, right? And we really have it kind of comes down between the fastest growing ones would be the steepest slopes. And it looks like between there and there is really close to 1920 to 1930. Like these two are super, super close to each other. And I'm probably going to have to erase what I have on there so I can really narrow it down. So let me look at it a little bit closer. From 19 uh, from 1910 to 1920, it looks like it goes from about 22 to probably 34-ish, maybe. And then from this one, it goes from that 1934 or that 34 to right at 40. So this one would have a rise. If we say it's 34, that would be 16. And if this is 34 and this is 23-ish, that would be a rise of only, let's see, this is 34 and this is 20, I don't know, 22. So that looks like it maybe rises 11. And I was wrong on that. It's not 16, sorry. It's going from 34, which would be 6, and then 5 more. So that would only be 11. Actually, to me, they look like they're the same. In which decade did the population grow the fastest? I would say it looks like a tie between 1910, the teens, and the 20s, is what I would say. And I don't know if there's a definitive right answer to that, because if you look at them individually, it doesn't look like that line changes direction. Although, you know what? Let's try this. Let's draw along that line. Oh, there's our answer right there. So if I'm right on that line, do you see how if it would have kept going straight, it would have stayed on that path? But since it kind of went down a little bit there, that's clear to me that it's actually steeper in this range than it is in that one. So kind of extend that out. That's a good cheat there to find out if it's steeper. So it looks like the teens. It grew faster in the teens than the 20s. So I'm going to say fastest from 1910 to 1920. And I know that because the slope of its line is steeper. That's how I know it's faster. All right. And that should cover you guys with lesson 7. I hope it was helpful. Sorry I rambled on number 3 for a while there, but we eventually got through it. And I think we have the right answer now. So y'all have a good one. Later.